All right, good morning, everyone. Welcome to the June U.S. grain weather webinar hosted by CropProphet. It is 10 o'clock. We're going to wait just a few more minutes to let the most people possible in, and then we're going to get started. Okay, we're going to go ahead and get started this morning. Again, welcome to the June U.S. grain weather webinar. We are very excited. This is the first webinar we've ever done. We hope it goes well. Everyone will get a survey after the webinar is over where you'll be able to provide your feedback. And we'd like to hear what you liked. We'd like to hear what you didn't like. And we certainly are interested in improvements. One of the points I do want to make is you can use the chat feature to ask questions, and I will try to answer a few of them at the end of the webinar if time permits. And again, thank you for attending. We're definitely looking forward to this interaction. Before we begin formally, I do want to highlight that we actually have also started some content on YouTube. And so on Fridays and Mondays, we're providing what we call the forecast of the forecast discussion. We're using our other tool, the World Climate Service, on Friday morning, we take a look at what Monday morning's ECMWF medium range forecast is likely going to be when you show up into the office on Monday morning. And then on Monday mornings, we actually review the forecast and compare what we said on Friday morning in terms of what we said the forecast would be with what the forecast actually is. So be sure to check that out on our YouTube channel. We actually just posted the Monday discussion before we started the webinar here. So I'm Jan Dutton. I'm the CEO of Prescient Weather. Prescient Weather is the creators of CropProphet and the World Climate Service. As a company, we focus on supporting commodity trading, both grain trading and power and natural gas trading. And I am assisted today by Christian Bowen. He has sort of helped made the webinar possible. Thanks, Christian, for your help. So as I say, search for CropProphet on YouTube. So to begin, we're going to take a look at May conditions. May really featured very heavy precipitation across the southeastern United States. Hopefully everyone remembers the significant rainfall that impacted Kentucky, Tennessee, and those regions. We see here from the map also North Dakota was substantially impacted by rainfall, whereas some of the core states, the I states, Wisconsin, were primarily dry. So on a crop production weighted basis, we see that the U.S. corn crop received 91% of normal precipitation, whereas soybeans received 99% of precipitation. So we like to use U.S. corn production weighted statistics because it's an easy way to boil down a complicated map like the one that we see here into a single number. And the way this works is for corn, for example, the counties that grow the most corn receive the greatest weight in a calculation of the overall rainfall received across the corn growing regions of the United States. And so while it's not necessarily indicative of local conditions, we see, for example, here a dichotomy between dry in the core of the Midwest when wet elsewhere. It does overall provide a good, simple indication of the conditions that the corn crop, the soybean crop, or the wheat crops received during the month of May. The time series evolution of the precipitation during May was focused on two large precipitation events, one right at the end of the month, one right just after mid-month. So we see a small deficit of 0.81 inches across the Corn Belt. So total precipitation of about 6.8 inches with a small deficit. In the top chart here, the gray band indicates the 90th percentile of prior historical observations. So if we ended outside of this gray band, it would be a very significant dry event. It'd be outside the 90th percentile of observations. In this case, we're really not that far from 50%. So although there is a deficit, it's probably not making news in here at the end of the month or during the month of May. In terms of temperatures, we saw generally cooler conditions again across the core of the corn and the soybean belt, sandwiched in between, very light, warmer than normal conditions. So on a production weighted basis, we see both corn and soybeans were minus 0.1 degrees Fahrenheit below normal. So they were essentially normal across the corn belt during the month of May. What was unique about the month of May in terms of whether it was corn production weighted temperatures or the soybean production weighted temperatures is the back half of May saw a significant cold period. So I mentioned the gray band, right? So here was one day where we see cold temperatures that were at the 90th percentile. So that's quite a cold, that was quite a cold day relative to prior years of history. We see an extended period here of almost 2 weeks of cold conditions. So in terms of June year to date, so this is data up through yesterday. We see, actually it's data through 07Z this morning, but we see the corn production weighted statistic at 136% of normal and soybeans at 131% of normal. As can be expected for the first 9 days of the month, the rainfall patterns have been fairly scattered with substantial rainfalls occurring of greater than 150% across Illinois and Indiana. The northeast corner of Iowa received rain, and then we see North and South Dakota were quite dry overall. But again, the fact that the corn production weighted precipitation for corn and soybeans is above normal suggests that there's not much of a dryness risk through today, basically. And in terms of temperatures, so far we see the western corn belt substantially colder than normal, temperatures up to 4 to 6 degrees below normal, and then cool conditions sort of scattered through the core of Illinois, Indiana, and just slightly warmer than normal elsewhere. So again, the corn production weighted statistics are rather benign at essentially 0. So no heat risk has occurred yet. And so if we take a look at soybean crop progress then, as a result of that May and June weather, we see that the planting progress was very early. And we're going to show a statistic that this is likely related, well, this is definitely related to producer behavior rather than the actual weather conditions. And as a result of the early planting progress, the percent emerged is also early as well for soybeans. And then turning to corn, we see that the percent planted progress essentially was normal, so it cut right through the middle. The emerged might be slightly early at the start and as essentially normal as of the last update. And we'll take a look at this data as well. And so we can look at the crop progress data from a historical perspective. So on the left-hand side, we see soybean crop progress relative to the 2005 to 2024 normal crop progress. At a national level, the crop progress is ahead by 5 days. And then we see variations by state with the greatest early progress focused on Missouri, but importantly, some of the major corn producing states are early. And really only we see here Ohio being a major producer is the only state in terms of soybeans that is behind, but it's only by 1 day and therefore insignificant. Corn on a national level is behind by 1 day in terms of the crop progress. And again, we see a substantial impact in Kentucky and Tennessee related to the very heavy precipitation that occurred earlier this year. But overall, the crop progress for corn is not in a dangerous situation. It's not significantly late at this point. So let's talk about soybeans, for example. In some of the analysis we did earlier this year, we showed that soybeans are planted earlier every year. And so what we see then on the x-axis for Illinois, Indiana, and Iowa is the year of the first non-zero planting progress report. And then on the y-axis, we see the date that non-zero report occurred. And there's a steady decline for soybeans in the I states towards earlier and earlier planting. And in fact, for 2025, the first non-zero reports for Illinois, Indiana, and Iowa were April 14th, April 21st, and April 14th, respectively. And so producers have really accelerated their early planting dates for soybeans. And that's one of the reasons why we see that the crop progress is so advanced so far this year. It's because of the behavior of the producers, not necessarily because of the weather. We can take a look also at crop conditions. So I want to highlight these are not the crop condition reports themselves, but this is a percentile comparison of where this year's crop condition reports compares to prior years. And those prior years are 2000 to 2024. So I'm going to flip to the next slide just to show what we're showing here. Focus in on Ohio. So Ohio is at 8%. And so what we've done is we've taken all of the crop condition reports in terms of the percentage of good plus excellent conditions for the corn crop in Ohio. And we basically ranked them, and then we placed this year's in that distribution. And so this year for Ohio ended up being 8%. And so this is a way of sort of standardizing the comparison of this year's reports relative to prior reports. So with that in mind, soybeans, the national percentile is 56%. So that's right around normal for this time of year. Whereas corn at 42 would be the corn conditions are slightly worse than what we've seen at this time of the year over the prior 25 years. We also see some of the states have been significantly impacted. So North and South Dakota, for example, have been significantly impacted by the heavy precipitation that they experienced in May. Ohio is negatively impacted by the heavy precipitation it has experienced. The opposite then is, for example, Iowa and Missouri are both very near the best seen at this time. So it's not the best, but it's very, very near the top of the historical perspective. And so this is significant because the CropProphet yield forecast model incorporates the crop condition reports. And so we can look at what has happened over the last 4 weeks with the CropProphet corn yield forecast. So just to take a quick step aside, the CropProphet yield forecast model it's 2 models that we combine together to create an overall national yield forecast. It is both a county level weather driven model and then a state level crop condition based model. And so we have 2 independent models using the county level weather data and the state condition data. and we combine them together at the state level to create basically an averaged crop yield forecast. And then we do the same thing for the national level. And so by tracking the difference or the changes in the yield forecast over time, we're able to estimate what impact weather conditions have had overall on the quality and the health of the corn crop. And so we see over the last 4 weeks, with an analysis updated through 2 days ago, that we see across the northern tier of the Corn Belt, we see declines in yield forecasts, whereas in the core of the Corn Belt, we see increases in yield forecasts. One thing that is worth highlighting is that Minnesota is the number 4 corn producer state in 2024, and Ohio is the number 9 corn producing state. The reason Minnesota being a number 4 corn producing state is significant is related to the fact that, interestingly, the correlation of Minnesota's yield departures from trend has actually decreased over the last 25 years compared to earlier periods. So what this map does is it compares, in this case, the Minnesota final yield estimate in terms of its departure from the trend compared to the US national trend for corn yield. So we see from 1981 to 1999, the correlation between Minnesota's yield and the national yield was 0.83. And for example, Iowa was 0.94. So that's one period. And the more recent period, the most recent 25 years, that correlation has declined to 0.26. We see some declines across the board in general, but the Minnesota decline is really quite substantial. So this year, the current model is decreasing the corn yield in Minnesota substantially. It's the number 4 corn producing state in the country, or at least it was in 2024. So it's certainly highly ranked. And what this suggests to us is that while it's not clear why the Minnesota and Ohio correlations are declining, we certainly have ideas that we won't go into here, but it suggests that a careful consideration of the Minnesota weather in the context of the national corn yield analysis is required. You can think of it as Minnesota may be decoupling from the national picture. And so when you're considering what the impact of weather conditions in Minnesota is, you want to try to do it somewhat independently when you're doing an overall national analysis. And then at the same time, the yield declines over the past 4 weeks for soybeans. Again, essentially the same pattern, other than in Kentucky and Tennessee, a gradual slight decline over the past 4 weeks, with the same areas being impacted by the May and June weather conditions. So we're going to take a look at the weather forecast. We've reviewed what happened in May and June, and it's worth taking a look now at the weather forecast. But before we do that, we want to take a look at when does weather matter most. So when does weather most impact the end of season yield and production for the United States? To answer this question, what we've done is we've taken a series of 30-day average weather conditions for each of the prior years from 1981 to 2024. And then we compare the 30-day average on the date shown to the end of season yield, where the yield is measured as the percent trend yield deviation. So to be perfectly clear, on the left-hand side, we're looking at precipitation. The y-axis is the 30-day precipitation percent of normal ending on the date shown in the top of the square. And the y-axis then is the corn yield deviation for an individual year. The same is true on the right-hand side, except we've done the maximum temperature. So the x-axis is the 30-day maximum temperature anomaly measured over the 30 days ending on the date shown. And the y-axis as well is the same deviation from trend yield analysis. And so what we see is that the most important period for precipitation in the month of July is towards the end of the month. So again, it's not a surprise, because it's generally understood that July is a critical month in terms of weather for corn. And so interestingly, for example, in maximum temperature, we see on July 20th a rank correlation of almost minus 0.5. So that's a fairly substantial correlation. One of the things that surprised me, having done this analysis, that there is a secondary period that matters for both precipitation and temperatures for corn. And in fact, for temperatures, the period is, or I should say, the rank correlation is actually higher at minus 0.57. And so we are now at basically the June 8th square, and we're headed into late June, where the correlations start to increase. And so this is why the summer weather markets tend to heat up towards June. They're hottest in the month of July. And interestingly, from our perspective, they tend to, proverbially cool off during the month of August. But this data would suggest that that might not be the wrong, that might be the wrong market response. But the point is that we want to start tracking weather in the summer, obviously. But the importance of weather conditions really gets important in terms of July and then August as well for corn. We can do the same analysis for soybeans. So for soybeans, we see for precipitation, we see a rank correlation of 0.4 around July 27th. So again, late July for soybeans. But interestingly, the temperature correlation tends to be lower, but also most important during early July. And just as with corn, there is a secondary maximum as well towards the end of August and towards middle September for maximum temperatures. So again, these are designed to try to quantify and objectively analyze when does weather matter most to the crops that are being traded. So let's take a look at the forecast information. We see from the ECMWF, the Euro, we see generally wetter than normal conditions across broad swaths of the Corn Belt. The corn production weighted forecast for precipitation is 107% of normal. For soybeans, it's 113% of normal. The chart on the right-hand side shows the full ensemble resolution of the U.S. corn production weighted precipitation forecast. I'm going to take a moment to explain what the heck it is that I just said. So each of the lines on the top chart on the right-hand side is a realization from the weather forecast model. The ECMWF actually creates 51 forecasts of the future. The reason this is done is because to start a weather model, we have to know the initial conditions of the atmosphere, which is we have to take a snapshot in time of what's going on essentially in the entire Earth's atmosphere, southern hemisphere, northern hemisphere, the full depths of the atmosphere. It's a very difficult task, and because, for example, the Earth is 70% water, it's hard to know exactly what's going on everywhere, and it creates uncertainty in the forecast. The atmosphere is also a nonlinear dynamical system, which is a complicated way of saying that there is a butterfly effect, and that very small changes in the initial conditions creates different forecasts further on in the forecast lead time. And so to solve that problem, the modeling centers run an ensemble. So they start the model with our best estimate of the initial conditions, and then they generate another initial condition that falls within the observed uncertainty, and they run it again. And they do it again and again and again. And so the ECMWF medium range forecast is a 51-member ensemble. Each of those gray lines on that top chart are theoretically equally probable. What most analysts do is we average it. So we average those 51 ensemble members to get the most likely outcome. And that is the black line in that chart. So the most likely outcome is wetter than normal conditions. And that is reflected then in the chart below it that shows an increase in the accumulated precipitation in this forecast lead time. And so the forecast here is for generally wetter than normal conditions across the U.S. Corn Belt. Now, we can also look at temperature in the same way. So on the left-hand side, we see the corn production weighted 14-day forecast from the European model is warmer at 1.1 degrees Fahrenheit above normal, and soybeans is 0.9. So it seems that that warmth is concentrated in the western Corn Belt as well as towards Iowa and northern Illinois. But again, it's sandwiched between colder conditions in the deep, deep south as well as in the northern states. And we also then see the ensemble outlook on the right-hand side, in which we're currently in a colder than normal condition period for the next week, roughly. It appears the forecast is for essentially normal temperatures and then a warmer period towards later June. However, there certainly is some variation in that as shown by the ensemble output as well. Now, it's also useful to compare the forecast. So this is content that comes from the World Climate Service, uh, but it's very useful, and I wanted to show it here. This is a selection of different models. So in each block, the upper left-hand corner is the European model. So that's the forecast for the model that we were just looking at. But then next to that, in the top row, is the Global Ensemble Forecast System. So that's NOAA's model. Below that is the Canadian Modeling Center forecast. And then below the ECMWF is the ECMWS AIFS model. And so the AIFS, just so you guys know, is an AI-based weather forecast model. And it is more of whereas the ECMWF, the GEFS, and the Canadian Modeling Center are physics-based models that attempt to model the physics of the atmosphere. The AIFS is essentially a complex pattern recognition model and is one of the hottest and latest trends. So in showing these maps and comparing the models, we want to look for similarities to gain confidence in the forecast, or we look for differences where we might question the accuracy of the forecast. And in each of the columns, then we have the 1 to 5 day forecast, the 6 to 10 day forecast in the middle, and on the right hand side, the 11 to 15 day forecast. Each of the models, other than the AIFS, is an ensemble forecast. So they are trying to sample the uncertainty of the initial conditions. And we know from our own analysis that the AIFS in the 1 to 5 day period is very competitive with the ECMWF and probably better than the GEFS. But by the time we reach the 11 to 15 day forecast period, the AIFS is not competing with the ECMWF and the GEFS. So what we see in the 1 to 5 day range, the models generally agree. There'll be some rain near Iowa, Minnesota, that region. Lots of rain in the southern part of the United States. And then we see in the 6 to 10 day region a good swath of rainfall across significant portions of the grain belt, with some question about what will happen in Nebraska and Kansas. And then finally, by the 11 to 15, we still see generally wetter than normal, normal to wetter than normal. And so the commonality amongst the models suggests that we can have a higher confidence in this potential outcome. We can also then look at temperatures as well. So it's the same setup. We got 1 to 5, the 6 to 10, and the 11 to 15 day forecast, where in the 1 to 5 day, the models generally agree. In the 6 to 10 day, we see the GEFS bring on the heat, and it continues on to the 11 to 15 day. And so there's different patterns of heat that occur in the 6 to 10 and the 11 to 15 day. I'm going to show you some data later. Actually, I'm going to show you some data right now that if you're questioning which model to take a look at, one of the things we've done is in those same time ranges, 1 to 5 day, 6 to 10 day, 11 to 14 day, we've been tracking the accuracy of the models relative to themselves. So the top row is daily maximum temperature forecast. The bottom row is precipitation forecast. And we've been measuring the mean absolute error of the ECMWF, the GEFS, and the GFS from rolling periods of 7 days to 90 days. So to be clear, the 90-day period, for example, is 90 days of error statistics that we've been taking a look at for the 1 to 5 day forecast, whereas the 7 is just the most recent 7 days. Green indicates that model was the lowest score, so the highest ranked, lowest error. Red is third place in error. Now, we always say that any model can beat any other model in any forecast at any time, which is why we have to look at the averages to know which models it is most likely that we should rely on. And what we see here is the ECMWF column has an awful lot of green on it. So there's a reason why the ECMWF model is the most tracked model. because it happens to be, on average, the most accurate model as well. And then we also see that the GFS tends to have a lot of red. So the GFS is a single ensemble member, and it is hard to compete accuracy-wise with a single ensemble member against, say, the ECMWF 51 member ensemble, because the ECMWF is much better at extracting the signal. So in terms of recent forecast performance and what we should focus on going forward, it certainly is best to focus on the ECMWF. But as I just showed, we can certainly use the models and understand how similar they are to try to gain confidence in the overall forecast pattern. So I mentioned our yield forecast. So we have a machine learning based model that takes weather information and turns it into yield forecast impacts. The yield forecast that we released today is current through the weather data through yesterday. But given that we have this model, we can take the year-to-date forecast with weather up to yesterday and then add on the weather forecast information. And once we've added on the weather forecast information, we're translating this complicated weather forecast into corn and soybean yield forecast impacts. And it gives us information about how the yield forecasts are likely to change given the weather forecast that has just been released. And so we can take a look at the corn and soybean 15-day likely yield forecast change. So given the weather forecast that we just discussed from the ECMWF model, we can expect the corn yield forecast to increase by 0.7 bushels per acre. And given the forecast we just discussed, we can expect the soybean yield forecast to increase by 0.3 bushels per acre. Now, it turns out that there are times in the crop growing season when the crops respond non-linearly to weather conditions. So when we do this analysis, we're not using the ensemble mean forecast to estimate what the impact of weather forecast would be on the yield forecast. We're actually running our yield model across every ensemble member. So in this case, the corn yield national change of 0.7 bushels per acre is actually the median of the 51 ensemble members. And the same is true for soybeans. And so what that allows us to do as well is it allows us to analyze the best case and the first case. So we have a sample of 51 possible outcomes of the future. We are looking at the median forecast. And so for corn, the best case scenario given 51 ensemble members was an increase of 2.6 bushels per acre in terms of the corn yield forecast. The worst case was minus 1.1 bushels per acre. So that's a fairly wide spread of potential forecast, and it's because there's a potentially wide spread of weather outcomes as well. For soybeans, the best case was 0.5, so an increase of 0.7 bushels per acre, whereas the worst case was a decline of 0.1. All right, and finally, we're going to take a look at the subseasonal forecast. So in traditional forecasting, a traditional weather forecast, you're looking 10 to 15 days in advance. And then the seasonal forecast, we're using some advanced techniques to try to look beyond that 15-day range. And this is content as well that comes from the World Climate Service. I want to highlight here that this is not an anomaly map for the 3-week forecast. So notice that we are looking at the 6th of June to the 12th of June. This is actually a probability map. So we are forecasting the probability that temperatures will be above normal, below normal, or within or normal. And each of these are considered to be the 33 percentile of the temperature distribution for this week for all locations shown. And so above normal, it means it's a fairly warm temperature if it occurs. What we see is the eastern corn belt shows increased chances of above normal temperatures 3 weeks in advance. And there's this persistent pattern of warm temperatures across the western United States that may likely impact the western corn belt. So that's 3 weeks in advance. And again, I should say to do this, we're using the ECMWF extended model. And this is we apply what's called calibration, in which we use a substantial set of historical data to improve the information that is available in the model. And by showing the probabilities, we're looking at the chances of a potential outcome rather than saying, for sure it's going to be above normal. We can look at the 4-week lead and we see the signal is not quite as strong, but the geography is important. So there's a slight chance of above normal temperatures across the core of the corn and the soybean growing regions. We can also look at the 5-week lead in this case. And so we see the continued warm signal in the western United States and in the eastern Corn Belt. In general, what we expect is as we go further out from 1 week in advance to 6 weeks in advance, the signals generally become weaker. But this is a case where, because we've calibrated the forecast, the frequency of the event should occur with the probability that we are suggesting on the map. So a 40% chance over Iowa, whether it's week 3, week 4, or week 5, should occur 40% of the time. And the key is these maps allow you to evaluate risk. The conclusion from this analysis certainly suggests that we can expect, all else being equal, we should be expecting warmer than normal temperatures in the month of July. I would love to show you precipitation as well. Unfortunately, precipitation is much harder to forecast than temperature, and the signal, if you will, is a wash. There's no particular signal that the model is pulling out, and that just means that we have to continue to watch the precipitation forecasts as we go forward. And then we also include the ECMWF extended forecast in CropProphet, and we also provide the weather impacted yield forecast analysis. And so interestingly, the ECMWF extended yield forecast change, which would be over the next 45 days, suggests no change in the yield forecast. So as a yield forecast change of 0.0 bushels per acre for corn, the best case was a plus 1.1 bushels per acre, and the worst case was minus 1.6 bushels per acre. So the ECMWF extended right now is not forecasting any dramatic events over the next 45 days that might impact the yields. So that concludes the webinar. Thank you very much, everyone, for attending. Do know that we're going to send out a survey when the webinar is over. We would really appreciate your feedback. We are going to conduct a July grain weather webinar. It's scheduled for Wednesday, July 16th. Because you've registered for this event, you're already on the attendee list. So thanks, everyone, for joining. Give me a moment so I can look at questions. Okay, so here's the first question that I see. So the question is, you mentioned you use the median of all the ECMWF ensembles as input to your weather model. Can you please expand on that? Do you run all 51 ensembles separately and take the average of the resulting yields from your model, or do you use just one single ensemble? All right, great question. So the ECMWF is a 51 member ensemble. We run the yield model using all 51 weather forecasts provided over the 15 days available. So it's 15-day forecast, 51 different models. And what that gives us then is 51 estimates of the corn yield forecast 14 days from now. And so in terms of the median, right, we rank those and you pick the middle one. That is the median outcome. So it is and the key is it's not the mean. And then when we're doing the best case and the worst case analysis, we are taking the highest ranked outcome is the best case, and the lowest ranked outcome is the worst case. And then there's multiple cases in between. I hope that answers the question. Great. So there was a question about what model has the best track record. So I showed data over the last 7 to 90 days. But in general, the ECMWF is known to be the most accurate model. I will say, and I just want to highlight, I talked a little bit about the ECMWF's AIFS model, their AI based weather forecasting. So we've been tracking the accuracy of the AIFS, and it is very competitive with ECMWF in the 1 to 5 day range. And then that tends to that skill, that very competitive skill, tends to drop off with lead time. So that by the time you reach the 11 to 15 day range, the competitiveness has dropped way off, meaning it is not as accurate as, in this case, even the GEFS. However, later this year, the ECMWF is going to release an ensemble version of their AIFS, and we expect that may solve some of that problems. There is a question on if we plan on doing webinars for international markets. I'll be honest and say we're going to see how this summer turns out, and if the webinars are popular and it's providing useful information to grain market participants, we are certainly going to plan on doing some for probably South America in what would be the Northern Hemisphere winter. I think with that, we will end the webinar. Please know you can email info@CropProphet.com to have your additional questions answered. And if anyone would like a PDF of the presentation that I provided, we're happy to email it to you. Just email info@CropProphet.com and we'll reply with it. Thanks everyone for joining. I hope it provided some valuable information and valuable insights. And if it didn't, please tell us in the survey. Thanks a lot.